What is up everyone, how it's going? My name is Anthony and in this video we are going to create our own custom virtual machine so we can write smart contracts and replicate our state across all of our nodes. But first of all, if you like DeFi, crypto or blockchain engineering in general, this is the place to be. This is definitely a channel you should consider subscribing to. Now let's get back to work. So let me quickly do a git log as usual, and we did our basic VM implementation, but right now we're gonna make it much more sophisticated. So let's open up VM, go, and let's see. So basically the issue we had, the issue we will have is this stack. So the stack is basically a slice of bytes, and that's a problem because we will have integers on the stack, but we will also have strings or bytes on the stack, or even slices of bytes on the stack. And we can't because it's just a slice of bytes. So what are we gonna do is basically, let me adjust this mic real quick. What we're gonna do is we're gonna delete these things, and we are gonna implement a stack data structure which will hold the data, and that's going to be a slice of any. And for the people that don't know, what any is basically just the interface from back in the days before Go had its generics implementations. You should use interface with those brackets, and I didn't like it. And now they have like a type alias, which is any, and it's much more cleaner, much more better to read. So the data on the stack is going to be anything, and we're going to have a stack pointer because we will need it. The stack pointer is basically a thing that points at where we are at our stack. All right, what are we going to do? We're going to make a constructor, new stack, which will return a pointer to a stack. We're going to say stack. What the hell is going on with this crazy editor? So we will have data, which is going to be a slice of any of size, which we will specify here. So it basically means that we can give it any size, so we can pre-allocate our stack, so we don't need to, under the hood, we don't need to grow the array on the fly, which in our case will take a little bit more of memory up front, but it will save us some space. And our stack pointer will be 0. And then we should have some functions, some helper functions for this thing. Let me put myself in a comfortable position. Okay, we need helper function, push. We need to push values on the stack. It's going to be a value of type any, and it will return completely nothing. We're going to say that the data at our stack pointer is going to be the value we give it, and then we're going to increment our stack pointers. So we push a value, increment a pointer. Push a value, increment a pointer. Easy. Classic. Basic stuff. We also need to have something called pop. It will return any. We're going to say, because it's a FIFO queue, which basically means first in, first out, we always gonna extract, we're gonna get the value, the first value on top of the stack. Well, on the bottom of the stack, basically, right? Which is data 0. The first, in our case, the first piece of our stack, if that makes sense. So we get the value, we store in a variable, and then we gonna return this value, but we also need to shift these things. So it's, let's do it in a dirty way. We're going to say the data is going to be append as data zero, I assume. Not sure. Let's test this out. So we delete basically in an array, in a pre-allocated array, we delete the first value. So we pop it. But the problem is it's going to be, we need to shift the array back one slot. And that's exactly what this function does. Let's make a function, a test function, test stack t, testing t. Let's make a new stack, 128. Let's push 1, 2. That was quick. All right, so pushing is working. So if we now want to pop the value, we can say that if we pop, it should be 1. Yeah. No. No, Anthony, what the hell are you doing, my man? It's gonna be 1. Because the value is perfect, but it's we didn't pop it because 1 is still in the array. But not anymore, so it's good, right? So this is working. So we pop 1. All right, and then we can say, let's pop again, and then it should be 2. Boom, let's go. All right, cool, that's working, fine, nice. Okay, so we have our basic stack operation shenanigans. So let's modify this thing. So this stack pointer can be gone because it's in our own data structure. It's going to be a new stack. Let's do 128 because for now. Going to be a pointer to a stack. And then we will have some issues right here because it's going to be VM stack pop int. Same thing here, we pop it, we cast it to an int. Why do we need to cast it to an int? Because the stack, the data on the stack is of type any, which basically means it could be anything. So we need to hint our program that we are getting ints, and that's because we're adding, right? So if we are adding, we know we are adding integers. And for now, it's basically the int type, but actually we should use something like a big integer type, because if we are working with floating points, we need to store those floating points into an integer. And to do that, we need a big int, because an integer, the space allocated by our computer is not enough to allocate floating points. It should be of type 256, int256, something like that. int256. But that's for later on. First, let's make this improvement. So we pop the first value, we pop the second, we can add them, and then we can push this value, stack push. We can push this value into the stack. Problem. What we should do is, instead of calling this instruction push, we should call it push int. Why? Because, oh man, I'm getting cold. Because we are also going to implement strings very soon, in a couple of minutes. And then we actually are pushing bytes onto the stack. So we need to hint the virtual machine what kind of type we are pushing onto our stack. And in this case, we can call it push int, and then we could say push is going to be an int because we concatenate, we add two ints together. So C is going to be an int, so it's all fine. And this can be gone. Push stack doesn't work. It's stack push int. Why? No, push like this, and then we cast it to an int, right? Okay. Let's do this for now. Let's let it run. Let's run. Right, blockchain. VM stack this data maybe. VM stack SP. Should work, right? All right. What I want to do real quick is see what's actually happening. Bring the land. What's going on here? VM stack data. Let's see what's going on. All right, so the cool thing is it's working. That's a good thing, the good news. The bad news is that we made a mistake. Because if we see, so if we check in our stack here, we see two nil values and then we see the 4. So basically the 4 should be up front. And the reason why this is not working is the do, if we pop, we should actually decrement our stack pointer. And where is this beast? Pop. We get the value, we shift the array, and the stack pointer is going to be decremented. I'm so sorry. Okay, so let's run it again. Boom, 4. All right. So let's test this real quick. We say assert, and we know this is not correct. This can be 4. We could say actually to get the result, the result is going to be on the stack. So we could say VM data stack, VM stack data. No, we can just pop. Just pop and then say result, right? Why is it 4? Because we're doing 2 push add, so 2 plus 2 is 4. Yes, we did it. All right, that's the easy way. So we can add integers with our new improved VM. Now it's time for strings. So how does strings work? A string is nothing more than an array of bytes. So instead of using push int, we are going to add an instruction that is called push bytes. So what is going to happen is we are going to tell our program, hey, the VM, we're going to tell it, hey, this is the length of my string. Then we're going to say, hey, push this byte. Push another byte. Push another byte. And then we say pack, which basically hints the virtual machine that we need to pack n size of bytes that are on the stack. If that makes sense. So, how are we gonna do that? First of all, let's make an instruction. Instruction push byte. Why is it not type hinting? Instruction. It's gonna be C. And now we're gonna make another one, and we call this back. A, B, C, D. All right. So, we're gonna make another case statement here. We're gonna say case instruction push byte. You're gonna say VM stack push byte, and exactly the same thing. Boom. And if you want to know how to be as fast as me in your editor, you should learn Vim. You should learn the Vim commands, and then you can do all this crazy stuff. And you never use your mouse. I never use my mouse. I never use it. Sometimes when I need to do this, and then I need to pick between these shenanigans here. But besides that, I'm just doing everything with the keyboard. And you should too. It will probably take you a couple months to get used to it, but it's gonna pay off at the end. If you want to be a high value engineer, you need to learn these keybinds. Not specifically Vim, but just something that you can throw away your mouse. All right, let's get back to business. Push byte. So let us make a new test. Func test stack string or bytes or whatever you want to call it. Testing T. All right. New stack. Call it. I want to know. Nobody cares. I'm thinking about what's the hexadecimal representation of A. I think it's 61. So we could say as push 61 So let's push 2, right? And we're gonna make the program. We're gonna make the program in any moments further. So we push 2, which basically says, okay, we push 2 onto the stack. We give it 2. Wait. How can I actually test this? Man, I'm confused. Yeah, because we push it. Okay, 1, 2, up, and then we back, which basically means to this, to this. Okay, cool. I'm thinking, how can I? Let's just delete this. Copy this data thing. So what we're gonna say is, we're gonna say length of 2. We're gonna push this to the stack. Then we're gonna say (61), which is the letter A. We push bytes. So we are programming in our own fucking language. Where is my push byte is C. So this is the A, push the byte. We make another A. We say push the byte again. Then we're gonna say pack. Boom. It's not gonna work. We're gonna print VM stack data. Okay, cool. What's gonna happen? Because I don't know. All right. So what we need to do is case instruction pack. What we're gonna say is so first of all, we're gonna fetch the length from the stack. So we say VM stack pop as an int. Okay. Then we say B for our byte slice is gonna be, we make a slice of bytes. And the length is going to be the length we just popped from our stack. And I think we could do something like this. Yeah. B y equals VM stack pop as a byte. And this is crazy, actually. I'm not gonna lie. It's on the top of my head, so I need to think and talk, and it's insane. It's insane. It's a gift, trust me. And then we need to VM stack. We push our slice onto the stack, and if it all goes well, and I really hope, because let's test this thing. Hey, you see? So we push this thing onto the stack, and I'm gonna make it even more better. So we do push this, so we can do this, boom, boom, and then we make this tree because we add another ladder. And then what we're gonna say is, so the value is gonna be VM stack data, pop result, actually, right? And then we're gonna say print a string of the result. What the hell's going on? Okay, buddy, it's all good. This is gonna be another byte. It's gonna be a byte slice. So I'm gonna do something really cool. Let me quickly search Google for hex letter shenanigans. Ooh, and I have this new light, and it's making me blind. So where's the letter F? 31. And then I need 14. 40. 3140. 3140. What the hell's going on? 3140. Shit. What the fuck is going on? Wait, come on, please, fast. 31, why is it? What the hell's going on? 40 then. Is this a wrong list or what is this? Oh, it's 4F. 646. Man, people are lying to me. 46. Is it? It is. Okay, cool. And then 4679. 79. Man, I'm breaking this thing. 79. Okay, please let me. I have the wrong fucking ladder once again. Anyway, it doesn't. It's the light in my eyes. Foo. We're programming. We are programming on our own VM. Some bumpy roads, but we are programming on our own VM. So, what can we do? We can make... So let me make this test. Real quick. So we are actually... Result. Boom, 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 boom. Should work. Yeah. All right. Nice. Cool. How many minutes do we have? 27. 27. All right. So basically what we did is we refactored our VM so we can actually have any arbitrary kind of data on our stack, which will be hinted by our program, which will be hinted by our bytecode, so the VM knows exactly what type of value that's on the stack. We can push integers on the stack, we can push bytes, and we can use pack, and the pack instruction will create and will pack everything into an array. And if we can pack things into an array, if we can pack bytes into an array, we can make strings. It's as simple as that. Yeah. I'm thinking, what can we do a little bit more? Maybe we should do something like, for example, we have instruction add. Let's make a simple instruction and we call it instruction sub, which basically means we need to add it. A, B, C, D, E. And normally we should actually kind of group these things, but whatever it is. If you want to reorder these things, feel free to do so. Instruction sub. So what do we do? The same thing as add actually. The only thing we do is make it a minus. What's going on here? Undeclared name. All right. So if it's all good, we can actually do subtractions. So let's do this. We take 2. Let's make 3. We push it, 2, we push it, and then we do sub, which is E, I guess. So that should be T1 result actually. Should be an int. And of course we only support unsigned ints for now. What the hell is going on? Result. All right. And that should work. Yes, cool. So we can subtract. So that's basically how we make a virtual machine. And the cool thing is we can use strings. So that basically means that the next episode, we are gonna implement our state. Because what are we with a virtual machine is if we cannot modify a state, if we cannot store that value into our blockchain and replicate it across all our machines, that would be insane. So that's the goal for the next episode. Maybe that episode is going to be a little bit longer because we are going to implement a state. We're going to use our virtual machine. We're going to create our own program where we will store a value into our state and replicate it across all machines. And that's amazing. And these things can only be learned at this channel. If you like this video, if you like what I'm teaching you guys, please subscribe to the channel, like the video, put a comment, ask questions, and ring the notifications bell so you will be always notified when I'm online for all this good stuff. Thanks for watching. See you in the next video. Bye bye.